Physics, as told by a physics graduate student at IU. Here at the Integrated Science and Accelerator Technology Hall, otherwise known as ISAT Hall at Indiana University, we're going to answer some questions that high school physics students might have about physics. When should I start to take physics?
Up until the very end of high school, I didn't think I was going to like physics at all. I put it off actually as far as I possibly could. And then I got into physics class and I found that I really, really liked physics, which made me really upset that I had put it off that long. It was my senior year of high school and I didn't have time to go on and take AP physics if I had wanted to do
So
that.
lesson number 1, start early, and if you like it, you can go on. And if you don't have to go on. What if I change my mind after I start college?
So I started college thinking I was going to be a doctor, and then took some classes, discovered that they weren't really for me, didn't do as well in biology as I would have liked, because I'm not a memorizer. I can't do it very well. And I actually stumbled upon a lecture by Dr. Susan Klein here at Indiana University about medical physics.
But why would I want to study physics anyway?
Well, first of all, a study in physics opens doors for like everything. And that may be because, as we mentioned before, it's such a base science. There's math, and then there's physics, and then there's chemistry, biology, and then I think it goes into psychology, sociology. Everything builds up from math, really, but physics is the bottom science there.
What kind of physicists are there?
Theoretical physics, it's very mathematical. You come up with a theory, it is then subject to experimentation. So that's your classic physicist. That's kind of what you think of. And this is Sheldon Cooper in The Big Bang Theory. Oh, and then on the other hand, you have your Leonard Hofstadter, your experimental physicist. Which is more hands-on. It's not quite as mathy. You have to understand the math, but you're not necessarily calculating something that hasn't been proven yet. You kind of, in a sense, you know what you're looking for. Yeah, so those are the two branches. You start with the theory, and then once you have a theory and you have a paper written on it, it's then subject to experimentation. You give it to the experimentalists. They take over. They try to prove this right or wrong.
So what does it look like in real life?
Let's use an example here. I am in experimental physics right now for my internship. And I built a system, which we'll go down and we'll see shortly. And we are searching for a fifth force of nature. Yes. And this is all hands-on. We build stuff, we design stuff, we experiment. And then everything that we're doing is based on a theory that is described in a paper written, I think, in 1984, actually. So it's kind of an old concept by Moody and Wilczek, I think is his name, about this fifth force that they mathematically derived. I don't even understand how they did it. It's another thing. You don't really have to understand quite everything.
Let the Sheldon Coopers do that.
Yeah, let the Sheldon Coopers do that, and we Leonard Hofstadters will just take it from there.
Let's go.
Here we are down in our little dark room. This is where I work for Dr. William Snow here at Indiana University. So let's take a look inside. It's a little bit different, a little bit smaller than you might expect from, if you look at the Big Bang Theory. That's the modern example of physics, and all of their experiments are really, really big. This is just a part of a huge experiment that's actually going on at Duke University. So we have a ton of collaborators. Alright, so I'm going to take you through the part of the experiment that I had been working on. I'm making a setup so that we can measure the magnetic susceptibility of substances that we may be able to use at the experiment at Duke University. Inside this setup is a torsion balance, which can measure the magnetic susceptibility of liquids. Inside, it's got little magnets hanging on a string, and depending on the paramagnetism or the diamagnetism of the liquid that you put in there, it will change the magnetic field, and the balance can detect that. So there are some things that we need to control to make sure that we can get that as precise and accurate as possible. So we have, inside the balance, it sits on a tilt sensor. So we can sense exactly how much it's tilted, and we have it set right now, which is why I can't touch it, at exactly 0 degrees, which is amazing. Inside of there, we also have temperature sensors, thermometers, you know what those are. And outside of here, these are polyethylene beads inside little bags, just to make it easier. And this insulates the system thermally. This right here is mu metal. It's a special metal made of, I believe, 80% nickel. It has a very high magnetic permeability, which means that it draws the magnetic field lines in towards the metal itself, and we have two layers here, and that works to effectively reduce the magnetic field inside of the system, and we have two layers to get it as close to zero as possible. The last thing that we're worried about is vibrations. So you'll see that this sits on a very heavy marble platform, so just the weight of it should reduce the vibrations as much as possible.
Now let's recap. I should start physics early so I can go on if I like it, and I can find something new if I don't. Even if I start college with one major, I can always change my mind and pursue something else. There are two types of physicists, theoretical and experimental. In real life, physics isn't always big and flashy, but some everyday materials can be used to discover some pretty cool things.